Welcome to nuLUCA Pavilion. This is a Ladybug tutorial on temperature visualization. So we're going to learn some of the important features in Ladybug by building our own temperature visualization. This is just one of the Ladybug tutorials in the environmental analysis collection. A big part of what nuLUCA focuses on is computational design, more specifically computational design informed by living systems, so biomimicry and computational design. And Ladybug is a great tool to help us with this. And of course, it's critical when we're designing anything really that we understand the context, that we understand the environment where our design will exist, especially in architecture. And Ladybug gives us a lot of information related to our environment, a lot of stuff that an architect or someone designing a habitable space needs to know, like the direction of the sun and the intensity of the sun, the temperature, humidity, wind, and so on. And we have all this information for basically any metropolitan area in the world. And we get this information for every hour of the year. So we have a ton of information. How do we understand it and how do we use it to make geometry? We need to know the kind of information Ladybug provides if we're going to bring sustainability into a design project. We use this information to make design decisions. But with computational design, we can go beyond this. We can write creative scripts that interpret and combine this information in different ways. You have a lot of freedom once you know these computational tools. And the possibilities of what you can create expand even further if you also understand how nature deals with this same kind of information. If you can draw from the intelligence of living systems to process this information in order to create form, to generate geometry. So our computers can process a lot, but there's way too much information at any one point, at any point in time for any computer or any living system or any imagined system really to process. And nature has developed a lot of clever ways of sifting through and making sense of all this noise around us. And so algorithms in nature don't just manage this noise, they use it. And when we press play on these algorithms, they can all but guarantee a good solution will come out. That's what we see in life all around us. That play button has been pressed and life is constantly adapting and evolving, tuning and updating all the designs it's woven together, including the designs that make the designs. So it's because of this that a lot of metaheuristic approaches in computer science are modeled after systems in nature. Metaheuristics is just referring to approaches to problems that are too complex to feasibly ever find the single best answer, but metaheuristics can be used to find a very good one. And nature does this all the time. So instead of trying to understand everything at once, we can design simple rules for a smaller part of a system. And then when we let this small part of the system interact with more of the environment and with other small parts, all obeying the same rules, a new and sometimes unexpected and novel solution seems to build itself. And with a tool like Ladybug, the kinds of information we get to use is linked directly to how the design might perform relative to metrics related to comfort and sustainability. And so we can do this kind of performance analysis in real time at the earlier stages of design with a tool like Ladybug. And when we're focusing on performance so early on, when we're still in the conceptual stage at this point in the design process, that the underlying theory is the main thrust of the design, a cultural statement or expression, the community character, anything deep within or motivating the design, the theory behind it, can be woven together with and amplified by performative metrics, real-world consequences of functionality, energy use, material use, structure, and so on. And so anyway, this tutorial will focus on understanding the basics of Ladybug, understanding how to get data out of Ladybug, and how to use that data to start to generate some geometry. And in this tutorial, the geometry we'll generate will simply be a visualization of some important weather data about our site. So the weather data will manifest as geometry that we see, and eventually in other tutorials, as we think more about the implications of the data we have on a site, we can let that information shape the designs of our buildings or products or components. We can write a script that describes the environment and a script that represents our design adapting to that environment. And it feels more like letting a design bloom or come to life in a certain environment, letting it behave as a living organism might tend to do in that environment. So as Annie Murphy-Paul highlights in her book, The Extended Mind, a brick wants to be an arch. It settles into that form and it's strong in this form. And we see a similar sentiment, but a richer example, one closer to biomimicry, coming from John Warner, a leader in green chemistry. He asks, what does a molecule want to do? And so what are the tendencies that we can embrace? What are the tendencies that we can recognize so that we can work with nature rather than against it. The adaptation process itself, the process of a design finding its form, for example, makes the solution robust. That process is forging a strong solution. And in some cases, this means that if it's challenged or pushed out of balance, it will fall back into a good solution. Inherent in the design is it pulled back toward solving the problem. If we can bring this into our designs, we're doing something wonderful. It's an ambitious goal, but we can start simple. Today we'll just start with something very simple, but crucial to learn. And this in and of itself can be very valuable to be able to visualize weather data, to show clients, or to just help you as a designer more fully immerse in the space, to get a better feel for what's happening on the site. And in the next video, we'll do this. We'll jump right into Ladybug. The rest of this tutorial will be looking at different locations and different ways to visualize the temperatures at those locations at different times. So see you soon at the next video.